Glycobiology is anything that has to do with sugars. And sugars can be free in your body, can be free in your cells, but they can also be attached to lipids, but they can also be attached to proteins. And if they do so, they can even, cover the whole cell with a sugar wall, which really happens on most of our cells. And the study of what these glycans do, where they are, and what they do to prevent us from all kind of pathogens, for instance, that's in the broader sense, the field of glycobiology. Before, with mass spectrometry, we didn't have the separation yet to really define all the different glycan structures on a lipid or on a glycoprotein. But nowadays, with the higher resolution, the better separation technologies that we have, the better enrichment technologies that we have, and the better software that we have, we are now really ready to enter this field. And really, by entering it, we are almost, we're almost taking it over as well. Because I think any glycobiologist that didn't know mass spectrometry in the past has converted to be using also mass spectrometry to analyze their problems. We can measure masses, but we cannot measure structures that easily. In the past you used techniques like NMR and maybe even crystallography, but also those techniques have difficulties studying glycans. And so one of the weaknesses of mass spectrometry is that if we have two glycans that have exactly the same mass, but a distinct structure, maybe because they have a distinct linkage of the chemical bonds, then it's for us harder to distinguish them. The field is working on new techniques like ion mobility or spectroscopy to also distinguish what we then call isomers, because they have exactly the same mass. But it's still at the moment one of the challenges to cover by mass spectrometry in glycoproteomics. I've been a mass spectrometrist for 20 years now. I always am driven by that I want to do and show that mass spectrometry can do more than what it could do yesterday. So I'm constantly looking where can I bring this field further in applications as well. The field of glycobiology is there a very good one because there are still so many challenges to be overtaken. So where we want to work primarily on is can we detect the masses of glycoproteins and glycoprotein complexes better? Can we sequence them better? Can we get better information about which glycans are exactly attached on which protein, under which physiological condition? I can go on and on and on. There is still a lot of work to do.